Introducing Scrap, our smart classification real-time analytics platform. Scrap is an edge-powered smart bin that performs localized inference for instant feedback and automated sorting. The main benefit of Scrap is to reduce high contamination rates due to users' inability to categorize waste correctly. This AI on the edge solution aims to reduce latency and increase reliability of sorting of trash on rubbish bins. By accurately sorting on the edge, we are able to reduce costs by removing the need of double sorting at recycling centers. Additionally, we can provide the capacity information of different bins at different locations to users who are responsible for clearing the bins. This in turn will reduce the number of trips needed to clear the bins, as bins are only cleared once they are full. The sorting platform is built using a pen tilt mount, which is attached to two servos for actuation, one 360-degree servo and a 180-degree servo. A HX711 load cell is employed to facilitate interrupt-based awakening of different sensors in this project. Two cameras are employed in this project. The first camera is used for actuation to control the servo's direction and tilt. The second camera will be used to take photos and send to the model for inferencing. The result from the model, coupled with information from the load cell, spectrometer, IR beam sensor, and capacitance sensors, are used to determine the make and material of the trash. In our proof of concept trash bin, we created 4 compartments to segmentate different materials of trash: metal and Tetra Pak, plastic, general waste, as well as glass. Now let us take a look at the platform itself. The platform holds a capacitance sensor, spectrometer, as well as the IR brick sensor. The platform is supported by the pen tilt device with the servos attached. Below it, we have the load cell, which weighs and takes note of the weight of the object. At the neck of the bin, UV lights were installed to facilitate UV rays detection of the spectrometer. On the moving platform, a Aruko marker has been placed on it to facilitate platform movement tracking. A top view camera, which is mounted on an overhead cardboard frame alongside a white light, will be responsible for tracking the Aruko marker on the platform for actuation. A side view camera is responsible for taking pictures of the object on the platform and sending it to the model for inference. So both inference and actuation will be handled by a single Pi attached to the smart bin. Now for the physical connections in the Pi, this is the pin-out of the Raspberry Pi 5 used in this project. So for the 360-degree servo, it is connected to GPIO pin 20. The 180-degree servo is connected to GPIO pin 21. The capacitance sensor is connected to GPIO pin 16. The brick IR sensor is connected to GPIO 26. The weight sensor, or the HX711 load cell, is connected to GPIO 14 and 15. And the spectrometer is connected to GPIO 2 and 3. So the Pi on the smart bin will be connected to a MQTT broker, which will then relay information to a web server hosting the capacity for different bins. Now this information will be used by different users to collect the trash when the capacity has been reached, reducing the number of trips needed to be made. Now let's look at the pipeline diagram for this entire project, which shows the control flow and logic flow of how decisions are made. So it starts with an interrupt-driven wake-up, where the smart bin is in idle mode until a load cell detects weight. Once awake, it diverges into two separate paths. The first path does object detection and vision processing using the RGB camera. The second path starts sensor fusion, where it checks the inductive sensor first, and if it's not metal, it continues to check the spectral signature analysis to determine whether it is glass or plastic or other materials. So having two separate paths is good in the sense that it provides a little bit of redundancy, where if either path fails, there's a possibility of a fallback to deduce the material of the object. Now once done, results from both paths will be fused together and it will be a decision will be made. Next, a contamination check will be conducted, where the brick sensor will check for contaminated items such as liquids inside the bottles. Thereafter, it will perform actuation in parallel with the updating of the MQTT server, and which would update the cloud server as well. Now let us take a look at the edge in action. It is now scanning a metal bottle. We can see here that